Our next speaker will be Richard Baker. Richard is the head of sales division for UK and Ireland for Russell Finex. His presentation will be about food and honey filtration for industrial applications. A little bit background about who Richard is. Richard has worked for Russell Finex for nearly 24 years. His background is in chemical. He graduated from Durham University in chemistry. And shortly after graduating, he joined Russell Finex in London as part of a graduate recruitment drive. In this time with Russell Finex, he has worked with numerous roles, including being a test engineer, sales manager, before he progressed into senior management. The majority of his roles within the business have been directly involving end customers, giving him an insight into a vast area of manufacturing sites across the UK and Ireland. Russell Finex market is hugely diverse, covers industry sectors such as chemicals, coatings, ceramics, metal powders, wastewater, recycling and additive manufacturing. However, the largest part of their business is in the pharmaceutical and food industry. Hence, we are very pleased to have him here today. They have been, they have hence become a key supplier of filtration and sieving equipment to a wide range of major household names such as Nestle, Mondelez, Heinz, Kellogg's, and hopefully Richard will be able to share some of his insights today. Certainly, Russell Finex is a name to me, having worked in industry. So thank you for being here, Richard.
Thank you, Daniel. Appreciate the introduction. Right, thank you for the introduction. As Daniel says, my name's Richard Baker and I work for Russell Finex, and we're an engineering company and manufacturer of sieving and filtration equipment. What I'm going to talk to you about today is tell you a little bit about who we are and the reasons why numerous industries across the world use our equipment for filtration and sieving. We'll then look at the basic mechanics from an engineering perspective about how filters and sieves work. And then we'll look specifically at where we fit into the honey industry and how we help them with some of their filtration issues. We'll also cover a couple of other environmental sectors that sort of may be of interest to the wider membership as well. So, as you can see from that slide, we're approaching our 90th birthday. And in that time, we've built a genuine global brand. But we started in the UK, we're a UK company, and we design, engineer, and build in the UK to this day. Wherever possible, we prefer direct employees. We feel this gives us a chance to train our people to the levels we need to give our clients the service that they demand in various parts of the world. So for this reason, we have sales subsidiaries and offices wherever possible. You can see there we've got subsidiaries in the UK, the US, Belgium, India and China, plus numerous sales offices as well across the world. But some far-flung destinations, we do use agents and distributors as well, just to increase our global reach. As Daniel said in the introduction, our core market is food and pharmaceutical, accounting for sort of 50 to 60% of our business. But we are hugely diverse in the applications we sell to, examples being a recent one where we were sieving lunar soil for NASA. And another one is insect larvae for black soldier fly, which is also linked into the food industry and used as a protein source. So we're very diverse, and for this reason I always used to say that no 2 days were ever the same, but since COVID and numerous lockdowns, sadly a lot of days are the same these days, but we'll move on from that one. So why do we filter or sieve? That's the key question and defines why we're in business today. But fortunately, there are numerous reasons. The first sort of obvious one is to remove any undesirable products that you may have in your particular product. So a good example of this might be the paint industry. If you're making paint and you formulate your mix, you might want to make sure there's no coagulated particles or bits of skin within the paint prior to it going into cans, which you then sell to your customers. So remove bits that you don't want in there. Second reason would be quality. Now, and a good example of this is the 3D metal printing market, which was a big boom sector at the moment. So this is where printing machines are literally printing particles from metal powder. And obviously the particle size distribution within that metal powder is key to the quality of the part that you get, and hence the lifespan of that part. And since these parts are going in things such as aircraft, it's obviously quite vital that they've got the right quality of metal powder going into their parts. So that's a key reason. Another huge area for us at the moment is waste. Fortunately, all companies are looking to reduce their carbon footprint, and they're looking at the environmental impacts that they have. So we can help out in a lot of ways with companies in this area, particularly sort of wastewater, any processed water that they use in their industry, be that food industry or plastic manufacturers, for example. And another key sector for us is anaerobic digestion, where food waste is being processed, and we help fit into their market as well. We then move on to quality reasons. This often isn't thought of, but it is a key aspect of where we can help. So it's different to the point above where you're improving the quality. This is more safeguarding the quality, and in the food and pharmaceutical industry in particular, quality issues have high consequences. So if there's anything in your product that reaches the customer that shouldn't be there, and you need to do a product recall, then obviously this has a big impact both financially and on your brand. So it brings us on to that last point, where we're effectively safeguarding our clients' reputations and safeguarding their brands. Because of this last point, particularly in the food industry, it does have a lot of its own legislation, and there are numerous organisations that define their versions of good practice. And I've listed just a few there. So supermarkets, for example, in the UK, if you want your product on a supermarket shelf, then you have to go through their auditing process. And as part of that process, they insist that the sieving and filtration in the manufacturing process, because they want to be sure that the product on their shelf is safeguarded. And we work quite closely with most of the major UK supermarkets to keep them informed of the products we're producing, how we're developing certain aspects of our range. So we stay in constant communication with them. Another example is the British Retail Consortium. They also have a policy talks about foreign body detection and removal, and that's where sieves and filters fit in. And then finally, just as a third example, the American Institute of Bakers, although an American organization, they still impact on these shores, obviously in the baking industry. And they have a section in their policy on sieving and filtering, or as they call it, sifting and straining. So the key question is how do we do it? So it's probably a bit of interest to the engineers within your group. There are various ways to perform particle separation. For example, you could use centrifugal force, spin it around and separate particles based upon their specific gravity or density. The way our machines work is based on particle size. All of our units separate based on the size difference between the various particles. So for this reason, we can separate solid from liquid, or we can separate solid from solid, as long as there is a difference in that particle size distribution. The actual screen or media that we use to perform this separation varies from machine to machine, and we'll come on to that a little bit later. So some definitions. What is a sieve? Most of you may well be familiar with a typical sort of handheld sieve you may use if you do any baking to sieve flour, which a lot of people have been doing during the various lockdowns to keep themselves amused. So this is a typical sieve, but all of our sieves are automated. So they all have vibratory motors. So we're moving away from a basic sieve, and we're making units that are designed for industry. So if you look at the application there, you can see this motor on the left-hand side, which is a vibratory motor. It's an electrical powered motor. We've got some weights in there that have been spun around, and that creates an out of balance force, which gives you that energy that shakes the sieve screen. Product is then fed into the top, and you can see here the actual media of separation. So in this case, it's a woven stainless steel mesh, which gives the actual media that performs the filtration. So any particles fine enough to drop through the holes in that mesh do so and are ejected from a cone section that you can't quite see there. It's hidden by the base. Any products that are too large to pass through the holes in this woven stainless steel mesh, they work their way out and get ejected through this oversized outlet on this side here. You can see there are clamps around the unit. This is basically just to allow a quick tool-free removal of all the product contact parts should they need to be taken away for cleaning, or should you need to change from one mesh size to another for a different product, for example. This unit can also house a magnet which sits beneath the woven stainless steel mesh, and the magnet obviously removes any ferrous contamination that's in the product. And as I said before, this can be used on wet or dry applications as long as there is a particle size difference. It's all stainless steel contact parts, and any bits that aren't stainless steel, such as the gaskets around the edge of the sieve mesh, are food safe polymers. Then we move on to filters. Now, filters are specifically for liquids, and this is probably best explained with a cross-sectional view on the next slide. So there are three diagrams there. Ignore the two either side for now. This just shows the point that these units can be orientated in different directions, either vertically or horizontally, have their inlets and outlets in various positions to suit the factory. But we'll focus on the central image. You see the blue representing a liquid here with red oversized particles in there. So in the case of our filters, product is pumped inside stainless steel cylindrical screen, which you can see there with a cutaway section. So you can see the product, the liquid and the oversize being fed inside it. Any particles, in this case the red bits, that are too big to pass through the screen are driven down into the sump section at the bottom. Any liquid that's fine enough to pass through the screen does so, and due to the pump pressure or the line pressure, carries on, and that's this stream you can see here. So this may look sort of familiar, may not look too different to those of you who are familiar with sort of bag or cartridge filters, but the key difference with our units is this rotating shaft that you can see at the image there at the top. Now we use a motor to drive this shaft, and what this does is drive a wiper assembly, which wipes the screen and also pushes any oversize down into this sump section at the bottom. Now the key engineering point here is that this wiper stops the screen from blocking, and hence you don't lose any open area in the screen. And this is critical because it keeps your flow rates constant and keeps the pressures constant. And this is very important when it comes to filtering honey, which we'll touch upon a little bit later. So this 3D view just shows how it all pieces together. So it's designed to be easily removable and tool-free as per the sieve. It's all bayonet connected, so it's just twist and remove, so all the contact parts can be taken away. But this at the bottom shows the unique wiper system, which is being driven by this motor at the top when it's all assembled. And that's the bit that's wiping the screen clean and taking the solids down into this sump section. Now this schematic shows a manual valve there at the bottom, which is opened to remove the oversized contamination. But what you can do is automate this. So instead of pressure gauges, which you can see here on the inlet and outlet, we have pressure transducers. And as those solids build up inside the screen, what that does is register a differential pressure across these transducers that can then send a signal to the valve at the bottom, and the valve opens and ejects any oversized material or bits that you don't want in there, and it keeps the flows constant. This slide shows the actual filter screens being used. So you can see the two different options available. So this is the bit that's actually doing the hard work, doing the separation. So the one on the left there is what we call a fine hole screen. So this has holes clearly defined in 2 dimensions. The one on the right is known as a wedge wire screen. So how this works is that it has wedges running from top to bottom, and the gap between these wedges defines what can pass through. So this is obviously only filtering in 1 dimension. So the wedge wire screens aren't quite as accurate, but they do offer greater open areas, which gives greater throughputs, and they're a little bit more robust and can withstand more differential pressures. So when selecting the screen, it's really that balance of the quality of the filtrate that you get with the fine hole screen versus the real world demands of production, where you may have certain process rates to hit. So that often dictates which screen is chosen. I mentioned before that all our units are stainless steel with FDA options for the bits that aren't metallic. And this unit is designed specifically to expand on that a little bit more. So it takes it a step further. The mechanics of operation are exactly the same, but it allows us to meet the international standard for the hygiene of machines, and allows us to meet the EU framework number that's mentioned there for food contact materials. So it's taking our normal self-cleaning filter and taking it a step further to offer even greater hygiene. So in terms of the honey industry, this slide sort of shows where our units fit in, and that picture is taken from a company based in Norway, which we'll talk about a little bit later. But typically, when it comes to honey, we're filtering near the end of the process, so as close to packaging as possible. And it's mainly for aesthetic reasons, to remove any particles that are visible to the naked eye that you don't want in there. So bits of bee's wing or pollen or wax or things like that that you don't want in the end product. And typically we're filtering between sort of 20 and 100 microns to do this. Now, as I touched on earlier, we supply to a huge range of industries, and I'm by no means an expert in the field of honey at all. We have a few applications where we sell to it, but it's not a huge market for us. But from what I've picked up from the dealings I've had with it, there tends to be a little bit of scorn to filtering too fine. So the industry tends to prefer fine filtration or microfiltration over ultrafiltration. So rather than just bamboozle you with terms, I'll explain briefly what they are. So ultrafiltration is sort of between 0.01 micron and 0.1 micron. So that's very fine. Not quite so fine as that is microfiltration, and that's typically 0.1 micron to 10 microns. And then where we fit in is known as fine filtration or particle filtration. And typically we only go down to sort of 15, 20 micron is as fine as we go. So that tends to be our involvement in honey, anywhere really between sort of 20 and 100 microns. But I believe there are finer filtration methods that can be used if needs be. So the picture there, as I mentioned, is from a company called Honningen Sentralen in Norway. And for those who want further details beyond what's shown on the slide there, there's a good editorial on our website that gives an in-depth write-up. But they were a cooperative that produced 7 types of honey from various parts: Norway, Croatia, Argentina, Ethiopia, I believe. And they had existing filtration in place, but it was a static blade screen, so it wiped periodically. And what they were finding is the unit was blocking, and there was a lot of manual intervention required. Operators having to go in and clean the machine, which was obviously a loss of good, valuable production time. So they installed one of our units, and the key advantage was the continual clean that I talked about earlier. So because it's continually wiping the unit, it keeps the apertures open, the holes open within the screen, and that means that the throughput is constant and the pressures are constant. And this tends to be important for the very viscous liquids, obviously honey being a good example of that. But I have filtered products a lot more viscous than honey. Thick tomato paste, if you put on a spoon and held the spoon upside down, it'd just sit there and look at you, wouldn't drip from the spoon. So viscous that it was very difficult to pump. But once we could pump it and move it from A to B, we found that our filters coped very well because of the way they're designed and the way mechanically that they work. So from an engineering perspective, I think that's the key point to get across, that we keep the apertures in the screen open, which allows a consistency of filtrate and because of that, you're safeguarding the product that's going through it. So typically for honey, as an example, we can get throughputs of sort of 2,000 to 2,500 kilos an hour when processing honey. So to summarize, I would say it's obviously a natural product. So no two applications are really the same. It does depend on where you're getting your honey from, the different blends, what you're doing with it. So I'd say always assess the parameters if you're looking to filter it. Run tests and just make sure that the unit copes with the demands that you want from it. If you do all this, then there's usually a solution that is available out there, even if it's a slightly bespoke one that we can also offer. So final slide is more of a sales-based slide. Some habits are hard to get out of, but I won't dwell on this one too much. But hopefully you've learned a little bit about what we do, how we do it, and why we do it. And if anyone's got any questions, I am happy to try and answer.
Okay, thank you, Richard. If anyone has any questions, please put them in the chat box below. I actually got one question in. What are the specific challenges when filtrating honey?
Like I say, it's blends and where it's from. So when filtering anything, it's how much oversize is in there. So some blends can have a lot of contamination in there. So the more contamination, the harder it is to filter in a way. So you just need to be conscious of that. And as I said in one of the slides, I'd always recommend running trials with whatever technology you use, whether it's ours or others, just to be sure that it copes with all the different blends you may be doing. But yeah, the main challenge is probably the contamination in there.
Yeah, another question I got in from Anthony Antonucci. Do these filters require less heating of honey, thus preserving more of the beneficial or the benefits of honey?
Yeah, good point. It depends on your setup and your application. So that one shown in Norway, I think that was just after a heat exchanger. So we can jacket all our filters if needs be to keep the product warm. Typically, from my experience, it passes through the filter relatively quickly for the reasons discussed. So jacketing isn't usually required. So we just fit into the process and it passes through rather quickly. Yeah.
Okay, and Sandra is asking, do you see an influence on recrystallization afterwards, depending on these filters?
Yeah, not something I've typically seen. Like I say, we're not filtering super fine and it's passing through the unit relatively quickly. So it's not something I've come across, but I'm not a huge expert in, as I said earlier, the process as a whole. So it's not something that's been flagged for my attention.
Okay, I got another one sent directly to me. Do different flow regimes affect filtration?
Sorry, do different flow regimes or flow rates?
Flow regimes affect filtration.
Yeah, so obviously the higher the flow rate can be more difficult, but then usually we just size the unit accordingly. So higher flow rates don't really trouble us. The main thing, as I said earlier, is how fine you want to filter and the amount of contamination or bits that you want to take out of the honey. That they would be the two main parameters. Flow rate, we could usually size. We just go to a bigger unit that gives you more screen area, more open area, if you wanted to significantly increase the rates.
Does the separation techniques comprise the quality of the liquid being filtered?
No, so yeah, that'll be one probably more for honey experts rather than me. So obviously you're taking out bits that you don't want in there, but whether that would also take out good stuff that you do, I honestly don't know. So I know that honey companies use it and they seem quite happy. But yeah, I'd be someone who's more of an expert on what size you'd filter to, I suppose. Then obviously try and go as coarse as possible to take out the bits they don't want, but hopefully keep all the remaining good stuff in there.
I don't see any other questions. Let me just double check. Yeah, thank you, Richard.